This is Professor Pelton. This is part 3 of chapter 3, section 1. So we're going to plug things in to functions and get the output. So first I'm going to plug in something numeric. So f of 2 equals parentheses squared minus 3 times parentheses minus 5. So whenever you substitute in any level of math, right? Doesn't matter what level of math you're in, you always need to put parentheses to maintain the order of operations. Without grouping symbols, you do not maintain order of operations in substituting. So now plug in the 2, which is the replacement for x. So the function value at 2 is 4 minus 3 times 2 minus 5. So I do exponents first. So I get 4 minus 6 minus 5. I think we're good there. Okay, so f of 2 equals, let's see, that's minus 6 and minus 5. So that's minus 11 plus, plus 4 is what, minus 7? That seems good. So basically the function value of 2 is negative 7. Okay. All right, let's try something algebraic. So let's say the function value at x plus 3. So we're plugging in something algebraic. Okay, so same thing again. Parentheses squared minus 3 times parentheses minus 5. So make them a little bit bigger this time. So I can fit in the x plus 3, which is what's going in there. Because again, that squared goes to both things. And the 3 is going multiplied by both items. Okay, so it's very important. You put the grouping symbols. Okay, so f of x plus 3. So order of operations dictates that the exponents come first. So I'm going to square first. Okay, so after exponents comes multiply. So I'm going to multiply the terms. So I get x squared plus 3x plus 3x plus 3x plus 3x plus 9. Yep. Okay. So then minus 3x minus 9. Oh, I didn't put the x. I did not put the x. Let's erase that. Minus 3x minus 9. And then minus 5. All right. So we did exponents. We did multiply. Now we'll do add. So f of x plus 3 equals x squared plus 3x, because one of the 3x's cancel because of the minus. The 9's cancel, leaving me with minus 5. All right, so if I plug in x plus 3, my output is another function, which is similar, but just switches the 3x's. So let's say I do f of negative x. So f of negative x equals parentheses squared minus 3 times parentheses minus 5. So I'm going to plug in a negative x now. Well, here's the thing. If I plug in a negative and I square it, I get a positive. 2 negatives make a positive. Oh, wait a minute. I get the same thing back again. Interesting. Okay. Well, let's say I know the outcome is 5. So and we already know what f of x is. F of x is x squared minus 3x minus 5, right? So we know f of x. So that was already given to us. So I'm just taking it and setting it equal to 5. Okay, so x squared minus 3x minus 10. So if I minus the 5 to the other side, right? So it becomes a factoring problem where that's 1. So 1x equals 0. All right, so I get a negative 10, right? So negative 10 is either 1 and 10 or 2 and 5, but one of them has to be negative. Again, we're trying to get a negative 3, so it's clearly this one here. So positive 2, negative 5. So x plus 2 is equal to 0, and x minus 5 is equal to 0. So x is equal to negative 2, and x is equal to 5 are my two answers. All right, pause the video, try the student problems for yourself. Okay, let's say we're going to plug in negative 5. always to put parentheses first, because grouping symbol maintains the proper order of operations. Okay, now we need to follow order of operations. So if I square, I'm going to get 25. Now I need to multiply after I do exponents. So I get 10. And then last step is add, so that's what, 35, 42, right? So if I plug in -5, I get an output of 42. So our coordinate of -5, 42. All right, so we're going to plug in a binomial now. So f of x minus 4 equals something squared minus 2 times something plus 7. So that's something we're plugging in as x minus 4. So according to order of operations, we have to square first. So x minus 4 times x minus 4. Okay, so after we do exponents, we're going to multiply. So if we multiply, we get x squared minus 4x plus 16, right? So x squared minus 4x plus 16 minus 2x plus 8, right? Minus 2x plus 8 and then plus 7. All right, so we did exponents. We did multiply. Now we're going to add. Whoops, I wrote add. I should have wrote subtract there. So I'm saying one thing but doing another. Okay. All right, so we're going to add like terms now. So x squared would see minus 4, and minus 4 is minus 8. Minus 2 more is minus 10. And then we have a positive 16, a positive 8, and a positive 7. So that's what, 31? Okay. All right, so let's say we invert the function with a negative. So let's plug that in. So we get f of negative x equals a something squared minus 2 times something plus 7. And we'll plug in the negative x. So if you square a negative, you're going to get a positive, and 2 negatives make a positive. So you get plus 7x. Okay, it's not the same as what we did last time. All right, so in this case, we know the function is 6. That means x squared minus 2x plus 7 is 6, right? Because this is f of x, which we're just replacing there. So I'm going to minus 6 from each side. So I get x squared minus 2x plus 1 is equal to 0. So I'm hoping this is factorable. If not, you have to use quadratic formula. So 1x, 1x. It's divided by 1, but I'm not going to write that. So 1 times 1 is 1, which is double 1 or double negative, right? I think we want double negative in this case, because that'll give us -2. So x minus 1 is 0. So x is essentially 1 as our answer, twice essentially, right? Okay. And this same rationale, plugging stuff in, is used in algebra in high school for graphing, right? Whether it's in y equals form or function form, I'll do one, I'll have you do another. So I can plug in a table of values, and they're infinite, of course. I can plug in anything I want. So I'm going to plug in some negatives and some positives just to make sure it's balanced, right? So f of -2 equals 2 times -2 plus 4, which would give me 0. Then I'll do f of -1 equals 2 times -1 plus 4, which would be what, 2. Then I'll do f of 0, which is 2 times 0 plus 4, which is 4. Then I'll do f of 1, which is 2 times 1 plus 4, which is 6. And then f of 2 is 2 times 2 plus 4, which is 8, which doesn't always fit in the graph, but you never know. All right, so at -2, I'm 0. At -1, I am 2. At 0, I'm at 4. 1, 2, 3, 4. And 1, I'm at 6. 1, 2, 3, 4, 5, 6. And 2, I'm at 8. And of course, I can plug in anything I want. I can plug in decimal numbers in between too, so this is continuous. I didn't have to plug in whole numbers of -2 to 2. I could put the decimals in between. That's why you have to connect with a line, otherwise it's incorrect, because it's a continuous function. It's infinite number of inputs and outputs. Okay, pause the video, try the student problem for yourself. Okay, so I'm going to pick the same values here. You don't need to pick those values, but try to pick things on both sides of the axes. So f of negative 2 equals 2 times negative 2 squared minus 1, excuse me. So that's 2 times 4 minus 1, so that's 8 minus 1 is what, 7? So f of negative 1 equals 2 times negative 1 squared minus 1. So that's 2 times 1 minus 1. So 2 minus 1 is 1. So the function value at 0 is 2 times 0 squared minus 1, or that's just negative 1. That's easy, because 0. And we have f of 1 equals 2 times 1 squared minus 1. So that's really 2 minus 1, or just 1. Whoa, what happened there? Let me fix that. Okay, then we have f of 2 equals 2 times 2 squared minus 1. So we have 2 times 4 minus 1, so 8 minus 1 is 7. Okay, so at negative 2, we're at 7. 1, 2, 3, 4, 5, 6, 7. At negative 1, we're at 1. At 0, we're at negative 1. At 1, we're at 1. And 2, we're at 7. Which is what we should expect as a continuous line. Because I could have picked any numbers whatsoever, because it's a continuous function. There's an infinite number of numbers between negative 2 and 2, and they go beyond negative 2 and 2, obviously. All right, let's go to the last page. Okay, let's try the next ones here. Now if you do some. So we're going to determine f of 2. Okay. So f of 2. Oh, my pen's not working. F of 2. Oh, what's going on there? Let's go blue eraser. Okay. I got like a double one there. I'm not sure what's going on with that. I think it just glitched out. Okay, f of 2. So if I go to 2, this is my x value down here of 2, correct? So if I go to 2, it's going to go up this coordinate here, which gives me a coordinate of 2, 1, right? So I get a value of 1. Okay. Let's say I go to f of x equals 4. The function value is 4, right? So essentially this is y equals 4. That's what that's really saying, right? Because the function and the y value are the same. So if I go to that, what you'll notice is this is my y value of 4 here, right? So x has two different values. Okay, those two different values, if you scroll down, are negative 1 and 3. So x equals negative 1 and 3. So what you really have here is two coordinates, right? You have a coordinate of negative 1 comma 4 and 3 comma 4 are the actual coordinates on the graph, right? Whereas this original question, the coordinate on the graph was 2 comma 1, right? Well, that's your x value, that's your y value, that's your x value, that's your y value. All right, so I did the student problem. Now you pause the video and try the student problem. Okay, so let's say we try f of negative 1. So if I go to the x equals negative 1 on the graph, well, we already did that one. That's 4, right? We already knew this. Negative 1, 4 is our coordinate. We already knew that. Okay, what about f of x equals 1? F of x equals 1, right? So essentially we're saying that y equals 1, correct? So we do that. I'm going across the graph like this, right? I'm going to get two coordinates, one of which we already know. So we're at x equals 0 and x equals 2, correct? So we have 0, 1 and 0, 2. I'm sorry, 2, 1. What am I saying? Okay. So inputs to outputs is all I'm really doing, is reading them, inputs to outputs essentially. Okay, which leads us to the last thing, which is the vertical line test. So you can visually look at a graph and tell whether it is actually a function or not. So vertical line test. A graph in the coordinate plane is a function of f if and only if no if no vertical line intersects the graph at more than 1 point. Well, why does this work? Right? So the vertical line is an input, and the intersected points are outputs, right? And we hope to have only one intersected point. So here, this is a function. Well, why is that? No matter what vertical line I draw, it's only going to intersect the line once. Okay, this is not a function. And the question is, why is that? If I draw a vertical line, I can get more than 1 point, so it fails the vertical line test. Well, you might say to yourself, what if I draw one right here? That only intersects once, but it has to be no vertical line. Just because you can make some vertical lines that work, has to work for all vertical lines. This is a function, right? Because no matter what vertical line I draw, it only intersects once. Intersects once. Okay, here, fails here because it intersects more than once. Fails here because it intersects more than once. It passes here and passes here, but doesn't matter as long as it fails somewhere because it has to be no vertical line. So this is not a function. Okay, and this one tends to be one that's confusing the students. I'll put the little arrowheads on here because I couldn't do that on my computer earlier. It won't really make any difference to the outcome. The point is, no matter what vertical line I draw, it only intersects once. This is a function. Might not be a continuous function because there's a break in the graph, but it's still a function nonetheless. All right, pause the video. Try these student problems for yourself. Okay, so let's go through these. So the first one is a function, because no matter where I draw a vertical line, it passes, right? The next one is not a function. Oh, actually, no, that is a function. I'm sorry. Kind of looked like it was, but I'm good. No matter where I draw one, I'm only hitting it once, so I'm good. This one's not a function. That was the one I was looking at. Not a function. So again, that's 1, 2, 3 intersections, correct? Doesn't matter whether it's 2 or 3 or 5 or 500. If it's more than one, you fail. So this one's not. This one is a function, right? It's got a little bump in there, but it doesn't matter. No matter where I draw a vertical line, I'm still fine. And this is not a function. Doesn't matter where I draw, I'm going to fail. Except for the outsides, they'll pass there, but it doesn't matter as long as it fails somewhere. And this is not a function, right? Because this is a vertical line, and all vertical lines fail because there are infinite number of points intersected. Okay, that is the end of part 3.